All right, we are continuing along in the Passport to Advanced Math, and we're going to start with complex fractions today. So when you see something like this where you have a stacked fraction, think about it like when we talked about rational expressions. This is really a fraction divided by a fraction. So we can rewrite that as multiplication. I keep the first fraction the same, times I multiply by the reciprocal when I'm dividing, so x plus 2 over 2x. Now, I might want to put parentheses in to hold those common factors together. When we multiply, we go straight across the top and straight across the bottom. I have these common factors here that will simplify. So this is going to simplify to 3 over 2x, which looks a lot nicer than what we had. If you see any domain restrictions in the choices, we're just talking about what we're not able to divide by. So we're not able to divide by x equals 0. Or we're not allowed to divide by 0, which means that x can't be 0 over here. But we also have to think about common factors that we divided out. Over here, we divided out an x plus 2. So here, x could not be negative 2 because negative 2 plus 2 would cause us to divide by 0. We also have some other things where we might have to rewrite an expression in a different way. So here you've got x to the 8th times y to the 4th to the 7th power. We want to make this 7 a 14. So we have to figure out how we can do that. Well, 14 is 7 times 2. So essentially, I need to pull a factor of 2 out of both of those exponents. So that's going to be an x to the 4th times y squared. Again, just taking a 2 from the 8 and a 2 from the 4. Now raised to the 14th power. And if you wanted to double check your work, you could say, okay, 4 times 7, that gave me 28. Well, now 2 times 14 is 28. And you could do the same thing here. 8 times 7 is 56. Okay, well, 4 times 14 is 56. So these are equivalent forms. And then as far as the isolating quantities go, this is just solving for a missing variable, and you treat all of the other variables like they are numbers. So you have these formulas, and in this first one with the area for a trapezoid, we want to isolate this b1. I would get rid of the 1/2 first. So you multiply both sides of the equation by 2. So 2a equals b1 plus b2, and then we have that h on the end. So we're going to have to divide both sides by h. So 2a over h equals b1 plus b2, and then you're going to subtract that b2 over. When you do that, it's not going to be a common denominator with that 2a over h, so it just kind of gets tacked on. That's equal to b1. This next one with the volume of a right circular cylinder, you're solving for h. So we wanted to divide by pi r squared. You can divide everything by pi r squared in one shot, and that's just going to be v over pi r squared equals h. Over here, this one's similar. You're going to solve for h. It's 2 times pi times r times h, and we can divide by that whole product all at once. So s over 2 pi r equals h would be our equation. This last one here, solving for h, it's similar, but we might want to think about pulling this out as a fraction. So v equals pi r squared over 3 times h. To get rid of this, you're going to multiply by the reciprocal. And think of the v as v over 1. So over here, these are going to cancel. 3v over pi r squared is equal to h. So you're just kind of manipulating the expression to rewrite it in a different form. So for your assignment, you've got structure and expressions and isolating quantities.